When we think about securing AI, our minds usually jump to things like firewalls, maybe encrypted data, but the most unpredictable and honestly the most harmful frontier isn't the server room, it's the chat window. The real risk, the thing we really need to worry about, is what an AI actually says and does. And that's exactly why today we're going to break down how you audit AI output.
This quote absolutely nails it. Look, a hacked server, that's a threat we understand. But this is different. The new, kind of subtle danger comes directly from what the model is generating. A single bad decision from an AI, a tiny leak of confidential data, a recommendation that's biased. This is where the real damage happens. The AI's output, that's the new attack surface.
So that's the big question, right? How in the world do you build a safety net for something that can generate a nearly infinite number of responses? It sounds almost impossible, but the answer is actually in a structured, really methodical approach. All right, so here's our game plan. First, we're going to define what those real risks actually are. Then, we'll dive deep into the 4 pillars of a solid audit program. We're talking hallucinations, accuracy, bias, and controlling data access. And finally, we'll show you how to pull all of that together into one powerful program.
Okay, so before we get into the how, let's be crystal clear on the why. And trust me, it's a big why. Focusing on the output isn't just some academic exercise. It's because an unchecked AI can cause serious, tangible harm to any organization. I mean, think about it. We're talking about huge business decisions being made based on faulty AI analysis, or the system just accidentally leaking customer PII or internal strategy documents. Yikes. It could give biased recommendations for hiring, or just completely mislead users by confidently making stuff up. Every single one of these is a major incident just waiting to happen.
All right, let's tackle our first pillar, hallucinations. This term has become a huge buzzword, and for a really good reason. It represents one of the most unique and, frankly, challenging risks of generative AI. So here's the crucial thing to understand. A hallucination isn't just a simple mistake. It's when the model states something completely fabricated, but does it with all the confidence of a seasoned expert. It's literally inventing facts, people, or data sources right out of thin air. And that is incredibly dangerous. It can mislead a security analyst into chasing a threat that doesn't even exist. It can create massive legal liability if the AI makes up something defamatory, and it can just completely shatter user trust. Big frameworks like the NIST AI Risk Management Framework specifically call this out. You need valid and reliable outputs, period. Now, stopping hallucinations, it isn't just a job for the AI team. It's a total company-wide effort. The AI platform team, sure, they built the technical checks, but it's the security team that draws the red lines. It's the subject matter experts who review the flagged content, and it's governance that sets the ultimate risk threshold for the business. This leads us right into our second pillar, accuracy. Now, while hallucinations are all about completely fabricated facts, accuracy is a bit more straightforward. It asks a simple but fundamental question: is the AI's answer actually correct? See, unlike a hallucination, an inaccurate answer isn't just pulled from thin air. It's based on real data, but the conclusion is wrong. It might misclassify a phishing email as safe or give you some faulty technical advice. In a business context, these small inaccuracies can have absolutely massive consequences. And this is exactly why continuous auditing is completely non-negotiable. I mean, just look at this. Imagine your first model is 95% accurate. That's great. But then you roll out an update, and without proper testing, that accuracy could plummet. You have to constantly check that your so-called improvements aren't actually making the model worse at its core job. And again, look who's involved. Success requires a really diverse team. Data science designs the metrics, yeah, but it's the business and security teams that provide those crucial real-world test cases. QA makes sure these checks are automated, while governance defines what level of accuracy is even acceptable for a specific use case. Okay, pillar number 3 is a big one: bias and fairness. This is where the technical risks of AI crash right into major ethical, legal, and reputational risks. So what is bias risk? It's when an AI, often completely by accident, starts producing discriminatory outcomes. Maybe a security tool unfairly flags certain user profiles as suspicious, or a customer service bot falls back on harmful stereotypes. This goes way beyond just bad practice. It's a direct path to serious legal trouble. So how do you actually find this stuff?
The audit process here has to be proactive. You start with diverse inputs, representing all sorts of different groups and scenarios. Then you measure the outputs statistically to see if the AI treats any of them differently. You even use red teams to actively try and provoke a biased response. And then you use those findings to recalibrate the system, adjusting data, tweaking prompts, and building in guardrails to ensure fairness. And this is where that collaboration just gets even bigger, bringing in legal, HR, and ethics. And these teams are absolutely essential. They don't just review the output, they help define what fairness even means for the company. They set the standards that the tech teams then have to go and implement. It's a truly cross-functional effort. All right, that brings us to our final pillar, auditing for unauthorized access. This is where AI security meets classic information security. And the goal is simple. Make sure the AI doesn't become a backdoor to data that a user has no business seeing. The risk here is that a clever user could basically trick the AI into, say, summarizing a confidential document they don't have access to, or spitting out a customer's personal info. It's a huge deal. In fact, the OSP Top 10 for large language models specifically calls this out as a major threat. So the solution is a multi-layered defense. It starts before the AI even sees the prompt, with a gateway checking the user's permissions. Step 3 here is super important. It's often called secure RAG. That just means the system only retrieves information from sources the user is actually authorized to see. And then, as a final line of defense, the output gets scanned for any sensitive data before it ever reaches the user. This brings us squarely into the home turf of your core security and IT teams. Your identity and access management folks, your security architects, and your security operations center, they are all critical players in designing, building, and monitoring these kinds of controls. Okay, we've covered the 4 pillars: hallucination, accuracy, bias, and access control. But how do you combine all of them into a single, effective program that actually works? Well, it really boils down to 3 key things. First, your program has to be continuous. This isn't a one-time check. It's a process that's woven into the entire AI lifecycle. Second, it has to be collaborative with real ownership from everybody, legal, business units, you name it. And third, it has to be measured with clear metrics and concrete plans for what to do when a check fails. And that brings us to the final question. It's really no longer about if you're going to use AI, but how you're going to secure it. In this new world, your organization is responsible not just for your technology's actions, but for its words. So the question is, are you prepared for that responsibility?